Hi everyone, welcome to Networkers Nest. This is Manohar and today we are going to learn a very basic but really important topic of routing. We are going to learn route lookup process. But to understand that, let's first check how IP routing works and we can know where route lookup process take place. IP routing involves three steps. First is routing, second is switching, and third is encapsulation. Router looks for correct exit interface, and that is called route lookup process, our today's topic. And when router check route multiple times, then it is called recursive route lookup. Second is switching. There are three types of switching. First is process, second is fast, and third is safe. Then it comes to encapsulation, layer 2 rewriting. We are not going to dig into IP routing today. That's a whole another topic for another day. Let's check how route lookup process works. Suppose you have multiple routes for the same destination in your router, then how router will consider the best route among them. So to select the best route, it has some criteria. The first is longest prefix length. It will consider the route which have the longest prefix length. It will not check for AD value or metric value. So suppose you have a route X learned by a router with prefix length of /24, and we have one another route that is learned with the information of /32. /24 is learned by a router A and /32 is learned by a router B. Then it will consider the path by a router B because it has the longest prefix length. So the first thing, it will consider this one. The interface which is connected to router B is the correct exit interface. What if case this prefix length is same? This is also /24. The route learned by router A and by router B have the same information and both have the same prefix length of /24. Then how it will select the correct exit interface? The second thing is AD value, lower AD value. It will consider the route which have the lower AD value. Suppose the X route learned by router A having the AD value of 1 and by router B having a AD value of OSPF that is 110. Then it will take the path by a router A because this route is learned with the AD value of 1, that is lower AD value. Right? In case this AD value is also same, prefix length is same, and now the AD value is also same. Then the third criteria is metric value. It will check which route have the lower metric value. Now consider the metric value of router A's route is 10 and for the router B metric value is 20. Then it will consider the interface which is connected to router A because this has the lower metric value. Now consider one more case where this prefix length is same, AD value is same, and now the metric value is also same. What it will do? It will start to load sharing. There are two types of load sharing, packet based and destination based. Packet based is by default. We are not going to dig into load sharing. So I have make you understand how route lookup process is done and how it considers the best route from the routing table. To understand this whole thing practically, let's check the same thing on my screen.
Here you can see I have connected router 1, router 2, router 3, router 4, and we are going to test how directly connected route 192.168.14.4 is not preferred when we enter a route which have more prefix length by router 2. You can see on router 1 we have only 3 directly connected routes. I'm going to enter a route, but before that let's test it by a trace route. It is taking a path directly connected to 14.4. Now I'm entering a route with more prefix length by a router 2. You will see it is going to take path by a router 2 having information of /32 instead of directly connected route having information of /24. Here you can see it is taking path by a router 2 now. Now let's test the AD value. I am configuring OSPF on router 1 as well. I am already running OSPF on router 2, router 3 and router 4. Now if we check the routing table, you can see new routes has been added and there are OSPF route for the 43.0 and 23.0. Now we are going to see how 192.168.43.4 learned by OSPF is not preferred when we going to enter a static route by a router 3. You will see the OSPF route will remove and the new route will installed in the routing table. I have removed the old route. Now I am going to enter a new route for 43.4 by a router 3 having a AD value of 1 because that is static route. Before that let's trace it. You can see it is taking path by a 14.4 directly connected interface. Now I am entering a route 192.168.43.0 having the same /24 information, but it is a static route and having AD value of 1. Now you can see a static route is installed and old OSPF route has been removed. Here you can see OSPF route is removed and now there is new static route. So the second point, lower AD value is preferred. And if you see, I remove this route again and when we check the routing table, the old OSPF route will be installed, that is OSPF. It's in there but it's not in routing table when we enter a more preferred route. For the AD value, for the metric value, we can see we have /20/20. So let's check the metric. I am not going to influence metric, that's also approved. We are going to check the load sharing. When we have the same metric, I am entering 14.4 path by router 2 and router 3. Now you can see we have two paths for the same destination having the same prefix length, AD value, metric value, and when we do trace you can see it is doing load sharing. So everything is proved, that's it.
To join our classes, please write us at info@networkersnest.com or you can call us for more information.